We are going to begin our unit on factoring today. So part one of your notes is GCF and difference of squares. And in this video, we're only going to focus on GCF. We'll come back and talk about difference of squares another day. So greatest common factor. That is usually what we use for the abbreviation GCF. And in this case, what I want you to write up at the top is a definition of GCF, or greatest common factor, and that is the largest term that will go into all the terms that you have. Usually you guys have done this in the past with just numbers, and in this case we're going to do it with both numbers and variables. That's why I have the word term in there instead of the word number. So also, it would be important to know that this term would divide evenly into all the terms that you have. That's how we can use the word go into. That's the same thing as saying that it would divide evenly. So pause the video at this point and make sure that you have those written at the top of your paper. Okay, so we are going to factor out the GCF of the following expressions. So I'm saying expressions and not equations because there's no equal to there. So that's what makes this an expression. So I look first at the numbers. So I have a 3 and I have a 9. So the greatest common factor of 3 and 9 is 3. And now I need to consider my variables. So I have x to the second, and here I have x to the first. So the greatest common factor is going to be the one with the smallest exponent. So the smallest exponent between 2 and 1 is 1. So I'm going to factor out just plain x, or you can write x to the first if you want to. When you factor, what you're really doing is dividing. Remember we said that in our definition, it will divide evenly. So to finish out this factoring, I'm going to divide each of the terms that I have by my greatest common factor. So 3 divided by 3 is 1. And now I have x squared divided by x. So if you remember from what you've done in the past, when you have division with exponents, you subtract your exponents. So remember I have an understood 1 right here. 2 minus 1 is 1. And then for this one, 9 divided by 3, that's going to be positive 3. And my exponent here is 1. My exponent here is 1. 1 minus 1 is 0. Anything to the 0 power is just plain 1. 3 times 1 is just 3. So there's no x. So when you get x to the 0 power, you don't need to write an x. Close the parentheses. Okay, so now to double check this, to make sure that I did it right, basically what I need to do is distribute that 3x back into the parentheses. So 3x times 1x, well 3 times 1 is 3. X times x is x squared. All right, now let's do the other one. 3 times 3 is 9. And I don't have an x, so that x just comes over. 3 groups of 3x would make 9x. And if I erase a little bit of my rainbows up here, you can see 3x squared plus 9x is what I started with. So I got this one correct. 3x parentheses 1x plus 3 is my factored form. Now, I don't have to write the 1 in front of that. I was just doing that to emphasize my division. The way you're likely to see this in a multiple choice sort of way is without the 1 there because it's understood. Okay, let's do the same thing with this one. So numbers first, 6, 18, and 12. The biggest number that will divide evenly into 6, 18, and 12 is 6. And then I'll look at my variables. Well, I have x to the second, x to the first, and no x. So if I want to know what they have in common, well, I'm not going to be able to put an x this time because all 3 of them don't have an x. In order for me to have an x in my GCF, I have to have an x in every term in my original thing. And in this case, I don't. So again, I'm going to divide. 6 divided by 6 is 1. And then I've got that x squared that just comes down because I did not have an x in my greatest common factor. That x squared part is not going to change. All right, 18 divided by 6, that's going to be 3. And again, the variable part doesn't change because I don't have a variable out here to divide by. And then 12 divided by 6 is 2. So the factored form of this expression, my greatest common factor was 6. And when I divided it away, this is the expression that I had left. So that's going to end up being the factored form with the GCF. We'll learn more factoring techniques later, But so far, what we know how to do is factor out the GCF. Okay, let's look at this one. So 3, 9, and 3. What is the greatest number that will divide evenly into those? What's going to be the GCF of the numbers? The answer to that is 3. All right, now let's look at the variables. I've got x to the third, x to the second, and remember I have an understood 1 on this one, so x to the first. For GCF, I'm always going to pick the smallest exponent. So when I put my x out here, I'm going to have x to what power? It's going to be the understood 1 that I have right here, because the smallest between 3, 2, and 1 is 1. Okay, now let's divide each of those. 3 divided by 3 is 1. And then I have x to the third divided by x. I'm going to subtract my exponents. I had x to the third. I factored out one of my x's, so it makes sense that I would have x squared left. 3 minus 1 is 2. All right, now how about 9 and 3? 9 divided by 3 is 3. And here I have x squared. I factored out one of my x's. 2 minus 1 is 1. And then this one tends to throw people off a little bit, so y'all pay attention. 3 divided by 3 is 1. And then x divided by x. I subtract my exponents. I have no x left, so it's just going to be 1. Sometimes people get confused when this number and this number match. But remember, we're dividing right here, so I'm going to end up with a 1. 3 divided by 3 is 1. Don't subtract and get 0. You want to divide and get 1. All right, so that is the factored form we know how to do right now. All right, let's try number 4. Okay, so I have 10, 4, and 2. What will be the GCF of those numbers? 10, 4, and 2. The GCF is going to be 2. 2 is the biggest number that will divide evenly into 10, 4, and 2. And this time, just so you guys can practice with the signs, because this is going to be important later, let's factor out a negative 2. We need to practice factoring when we have a negative. Okay, now look at your variables. I have x squared, x to the first, and no x. So what should I write for my x right here? I should write no x because that's the smallest of the ones that I have. No x is the same thing as x to the 0 power, and 2, 1, and 0, 0 is the smallest. Okay, so let's divide by that negative 2. 10 divided by negative 2 is negative 5, and there is no x, so that's just going to come down. Positive 4 divided by negative 2, negative 2, and I'll bring that x down. And then 2 divided by negative 2 is negative 1. Again, I'm going to be dividing here, so I need to be careful not to subtract. 2 divided by negative 2 is negative 1. All right, notice what happened here. All the signs that I had at the beginning were positive. All the signs I have here in my answer are negative. So when I factor out a negative number, what that does is change all my signs. That's going to be really important. We're going to do that a lot over these next few weeks. Okay, let's try this one. 2x squared plus 4x minus 6. Okay, GCF. See if you can do the number first. What will be the number part of this GCF? It's going to be a 2. 2 is the biggest number that will divide into 2, 4, and 6. Okay, how about the variable? In this case, I'm going to have no x because this one has no x. It's not a common factor because this one doesn't have an x. So I'm just going to factor out 2. Okay, so divide out the 2. Tell me what you're going to get when you divide out the 2. Well, 2 divided by 2 is 1, so I'm going to get 1x squared, or I can just put x squared if I want to. 4 divided by 2 is 2. The x comes down because there's no x right here. And then 6 divided by 2 is 3. Okay, and then remember from before, if I want to check this one, what will I do to check it? Well, I can distribute that 2 that's in the front and make sure I get the same thing. So 2 times x squared, oops, I don't know what happened there. 2x squared All right, 2 times 2x. If I put those together, I'm going to get 4x when I multiply. And 2 times negative 3, that's going to be negative 6, which you can see is the same thing that I got when I started. So I know I got this one right. All right, last one. 2x to the third plus 4x squared minus 2x. What is going to be the GCF of this? See if you can get the number and the variable. Well, the GCF of this one is 2x. 2 divides into 2, 4, and 2. It's the biggest number that will. And if I look at my exponents, I have an exponent of 3, 2, and an understood 1. And the smallest of those is my understood 1. Okay, let's divide. Let's see what we get right here. You guys divide out, write it on your paper. Let's see what we get when we factor out a 2x. Okay, remember we're dividing. 2 divided by 2 is 1. You can put the 1 or not put the 1 in this case. 3 minus 1 is 2, so x squared. Subtracting my exponents, 3 minus that understood 1. All right, now let's divide. 4 divided by 2 is 2. And again, I'm going to subtract my exponents. I had x squared. I factored out x to the first. So I have x to the first left, which I can choose to put that 1 or not put that 1. All right, 2 divided by 2 is 1. And I had x to the first, and I factored out x to the first, so there's no x left, which means this time I have to put the 1. When there's no variable there, I have to put the 1. I can't just leave it blank. If there is a variable there, remember that's the same thing as x squared. I don't necessarily need the 1 coefficient in front of the variable. It means the same thing. But when I have a 1 as a constant, I have to write it down. That's not the same thing if I just leave that 1 out. So the final answer would look like this if you were on a multiple choice test. If you were typing an answer for me in Canvas and you type this answer in, it's equally as good and I will accept either one. Just be watchful that this is what you guys are going to see on multiple choice type tests.